Escaped Sapiens.
One of the defining features of science is that it should be reproducible. But recently there's been a growing recognition that many scientific studies are difficult or even impossible to reproduce. This is especially true in fields like the social sciences, where the societal context of a study may no longer exist, or in medicine, where a small number of cases or patients can lead to a small data sample with underpowered results. So is there a reproducibility crisis in science? In this episode of the Escape Sapiens podcast, I speak with Brian Nosek, who initiated a crowdsourced collaboration to find out. Together with 270 contributing scientists, Brian's reproducibility project set out to repeat 100 psychology studies. Their results, which were released in 2015, were pretty shocking. Only 36% of attempts were able to replicate original findings. So what does this mean for science? How widespread is the problem, and what can be done to fix it? This is a fascinating conversation, and I had a lot of fun recording it. I hope you enjoy. I wanted to ask you today about the reproducibility project, but before getting into that, I'm sort of curious, how did you get interested in reproducibility in science specifically? Did you think there was a problem in psychology in particular, or was it just academic interest?
It certainly did come up through my training in psychology. I went to graduate school starting in 1996, and in the early training of grad school, right, one of the courses was research methods taught by Alan Kasdan, and he had us read these papers from guys like Tony Greenwald and Jacob Cohen and Paul Meehl. These are sort of luminaries from the 1960s and 70s in psychology, talking about all of these problems in how the science is done. We ignore null results. We have a file drawer with things that we didn't quite work. The publishing system is out of whack. We use statistics wrong. And the class, the discussion is sort of shocking in that we're reading these papers. They're from the 1960s and 70s. This is 25, 30 years later. The papers document the problem. They document the solutions. And we're still talking about them. Like, oh yeah, boy, those are big problems. Yeah, we should really do something about that. And it was stunning because I came into graduate school with an idealistic vision of how science operates and thought that it was just, you study things and you ask questions and you figure out something and you figure out that you don't quite understand it, but then you share that with others and then everybody debates about it and then you go back and keep going through the cycle. But it became very clear that it isn't like that there is structural elements of the system that are different than the values that we bring and really are about the rewards that we get to be able to survive and thrive. And those have threats for reproducibility ultimately.
Okay, so there was an idea, people knew of the problem, but was it quantified as well as qualified?
Well, no, not comprehensively, for sure. And I certainly at the time didn't recognize the scope of what those challenges were, right? This was provincial, right? This was within psychologists talking to psychologists about these challenges. But the scope of it was documented to the extent of a couple of sort of key observations. So one observation was that almost every result published is a positive result, right? The researchers found evidence for the thing they were studying, right? 90% of the time, papers are finding positive outcomes for the hypotheses that they have. Simultaneously, analyses of the literature looking at statistical power find that the average statistical power is 50% or less. Now, what does that mean in consequence? Well, statistical power is suggesting that if every result reported is accurately estimated at the effect size reported, then 50% power means that we should see about 50% positive results. Mm-hmm. But we have 90%. So it just doesn't make any sense. So that part has been known since the 1960s and 70s. How is it that we could have low power where we shouldn't be detecting effects, even if everything is credible, and yet we have this massive positive result rate? But the actual how it translated into everyday practice and that the implications of that kind of discrepancy for replicability of findings didn't get systematic attention until this last decade in the field. And then, of course, this is now not just within psychology, recognition over time that these are systemic issues in many areas of science, not necessarily all areas of science, but many areas of science are wrestling with the same things.
In terms of systematic attention, I can still remember when I first heard about the reproducibility project. And I mean, I was shocked. It's a shocking result. And
Yeah.
it's also, it seemed like a huge undertaking. So maybe just to, set the context, maybe you could give just a brief summary or a brief overview, what was the project?
Yeah. So the main replication project that we're known for having pursued. There's a number of these that are variations of it, but the major one was a crowdsourced effort where we said, there is all of this supposition from the 60s and 70s. There's this sort of lingering evidence of challenge, but we really need to look at it and see if the doomsday consequences are playing out. And of course, not everyone is thinking doomsday. There's variations of levels of concern. But we're debating about replicability without doing replications. It doesn't make any sense. So we said, well, what we need, obviously, is to study it. Let's take a sample of findings from the literature and see if we can replicate them. Obviously, we can't do that at scale because the literature is big and we are small. And there isn't good rewards for replication. So it wasn't going to just be my lab and team that's going to do tons and tons of replications. So what we ultimately did was say, here's an idea of doing some replications. Anybody interested? And in the end, 270 co-authors are sort of part of this paper, where we ended up taking 3 journals from 2008, defining a sampling frame from those 3 journals of how we try to select papers to do a replication, select one experiment from each paper to do replication, and replicate as many as we could. Mm-hmm. And over the 3-4 year period, we did 100 studies. We have a replication of one of the experiments from those papers. And it was this grassroots sort of let's try stuff and organized a collective effort to see how many we could actually get done.
From each one of those 100, how many replicates was it a single replicate where you had a team from the 270, or how did
That's
that work
right.
out?
In this case, it was one attempt from one team to try to replicate each finding. And they had to hit minimum power. So the original effect size was the basis of saying, okay, let's make sure we have a solid powered test of that in how it is you do it. In the sister projects to that one, we have a set of 5 papers that are called the many labs projects. Mm-hmm. And in those, what we do is we selected ad hoc paper experiments that we could do replications relatively easily, and then did them in dozens of labs. Mm-hmm. So the same protocol, let's look at whether there's heterogeneity in how it is those effects occur, right? Psychology is a complex phenomenon of the things that we study. There might be variation by sample and setting. And so these 2 projects, one was sort of the reproducibility project was wide and shallow. The many labs projects are narrow and deep in how they try to look at replicability.
And did you find that the 2 studies sort of support one another and correlate?
Yeah, they sort of reveal similar results in many ways. The reproducibility project, what we observed ultimately was on the variety of ways you might try to say, did we succeed or fail at replicating the result? About 40% of the findings replicated successfully. Mm-hmm. In the many labs kinds of projects, we do about the same, maybe a little bit better, 50%, 60% of the findings that are selected replicate successfully, with massive power. But the important caveat is those are ad hoc selections, right? We're cherry picking studies because of different goals that we have for trying to look at heterogeneity and findings depending on the study itself. But the consistent observation is that the presumed credibility and replicability of the published literature was not revealed in what we were able to do in the replication studies themselves.
So you said about 40% there. What does that actually mean? Does that mean statistically significant results? Like what do you mean when you say that exactly?
Yeah, no, that's a good question, because what does it mean to replicate something successfully or not is actually turns into a very hard question. So one answer is, do we get a statistically significant result in the same direction as the original? Mm-hmm. On that criterion, we had about 36% success rate in the reproducibility project. Another criterion would be, okay, let's meta-analyze. We'll combine the original and the replication study and just take, this is the cumulative evidence. Of course, that presumes that the original evidence wasn't biased by publication bias and everything else, which everybody knows is sort of happening. So they're inflated a bit. But then you would consider the success rate around 60%. You also can look subjectively, right? So yeah, statistical significance isn't necessarily the right cue. It's also this bright line making a dichotomous decision. Let's just let the reader decide. Mm-hmm. Is the pattern the same pattern in whatever way you subjectively assess evidence? And then that replication rate's about 39% in the reproducibility project. So we used 5 different of these criteria just because we're trying to sort of triangulate on multiple ways one might conceive of it. And there's actually now a really robust meta-science literature of trying to improve the indicators of deciding replication success and what it means. Of course, all of them are limited to this sort of discrete thinking. There's an original study, there's a replication study, and we need to make some kind of decision about each study. And usually that's a dichotomous decision, worked, didn't work. When in reality, right, scientific evidence is cumulative, right? You do many studies and you aggregate them together, and that's your best estimate overall. So that's all sort of complicated in the mix of debates about what all of the results mean.
So it sounds like the debate is ongoing, actually, from the initial.
Yeah, it's not like we did the project and said, oh, yeah, okay, well, now let's move on. No, what happened was, whoa, what is that and what does it mean? And lots of different views. And that has been extremely productive, both within the field and as this is starting to branch out in other domains, is really wrestling with fundamentals of, okay, we observed that this was a challenge to replicate these results. Right? There's 3 obvious general explanations, right? The original result was wrong, right? False positives, and we're doing all of these things that are creating more false positive literature than we realize. Second obvious explanation is replication screwed up. It's a false negative, right? Mm-hmm. We just were incompetent. We didn't follow the protocol right. We didn't get expert input, whatever it is, the replication screwed it up. And then the third is that the theory is underspecified. So we thought we were doing a replication, but there are some changes in the methodology and the sampling and the setting that substantively affected the observation of that phenomenon. So both results are right, but we just don't understand yet why.
The parameter space is larger.
Yeah, exactly. And all 3 of those are plausible, likely, and must be having some impact, right? It is, I am perfectly capable of totally screwing up a study, whether it's original or a replication, right? If you ask me to replicate a neuroimaging study, I don't know how to turn on the magnet. It will fail. That's not an interesting one. But interesting would be where I think I did it right and might have failed, right? So there's where a lot of the debates are trying to figure out what is it among these different things is accounting for success and failure. And then what does it all mean, right, to replicate something or not? What's the optimal replication rate, right? There's just lots of really interesting questions to tangle.
So outside of the debate, were you shocked by the initial result, personally?
In terms of how low that particular result was, yeah, that surprised me that it was as low as it was. I was in the camp of, I think there is a real challenge here. Those early papers were compelling to me. And so the part of my motivation was to investigate whether their hypotheses about what should be the credibility of literature were on target in any meaningful way. But I didn't expect it to be that low. Now, whether that particular 100 studies is an accurate estimate or not, we don't know. So I don't want to overemphasize 36%. There's now a number of these different kinds of studies that in aggregate are, in the neighborhood of 50 to 60% replication rate in psychology findings. Now, that may be a better estimate or not, but the literature is vast. To me, the key point is we presume in each of these cases that these findings are credible. They're published, people cite them, people are building on them, people are extending those ideas in different ways. And then when we try to do them again, try to verify that quality of that evidence, we fail surprisingly often, whatever the ultimate percentage is.
If 36% isn't representative, would you be able to say where you if you had to draw the line somewhere today, if someone forced you, where would you place that line from what you've seen?
Yeah. So I think I would maybe put a confidence interval on it. I would have 80 percent confidence. I'm making up these numbers as we go here, so but sure, let's commit to something.
Sorry, I'm putting you on the spot.
No, this is great. I love being wrong, which I am a lot. So my 80% confidence interval would be 35% to 65% of a reasonable definition of the psychological literature pre-2017. Mm-hmm. How's that for qualifications?
It does not find statistically significant, and so
right. So of a good faith replication that's well powered and yeah.
Okay, I mean that is significant. I mean, so the reason why I find this interesting, in particular with the social sciences, is that social science research actually has an impact on policy, on what you do in a clinical setting, and so are you able to say, is there, what sort of impact does this have on a wider, downstream?
Yeah, no, it has the social behavioral sciences are having an increasing impact over time. And that is great because there's lots of important discoveries that have occurred in these areas. And the theories are maturing in useful ways. There's greater applicability of those findings. But of course, we want to be confident when we're translating from basic to applied findings. And the broader implications, and this is not just constrained, obviously, to social behavioral sciences, but the broader implications are the current systems of evaluation don't themselves give enough information about the credibility of the findings, right? Just because it was published in a one-word journal doesn't mean now that we can believe it. And of course, every individual scientist knows that, but we don't necessarily operate that way, right? Once it's in the literature, because there isn't an ethos of replication in many subdisciplines, then we're not doing the verification and cumulative confidence building process. The incentives are about innovation, innovation, innovation. So I think the broader impact is a lack of recognition of uncertainty of the findings. It may be that some we should have high confidence in and others we should not and we need to pursue further, but we don't know which is which. So one of the big innovative things that I think is happening now is working on early indicators of confidence in claims. So there are a few different things that I think have been really interesting in the wake of the replication efforts. One is surveys, prediction markets, and elicitation techniques to try to predict in advance, will it replicate or not? So in most of these projects, the many labs projects and the reproducibility project, a collaborative team of economists ran prediction markets on the studies, had people bet money, is it going to replicate or not? And the pricing at the end of when the market closed was quite predictive of replication
that
success.
Works. Totally. So you crowdsource
right, insight.
A belief in the result.
Yes.
Sort of.
That's right.
Wow.
And so
I hadn't heard of that.
So there's now 5 papers that have some good, strong cumulative evidence that surveys and then replication markets, perhaps even a little bit better, are able to predict the outcomes.
Did you run that on your initial sample?
Yeah, so 41 of those 100 we were able to do prediction markets for, because the project started sort of midway. We had already had some collections underway, so we said, let's not try to do markets on things that are already happening. Let's do it prospectively on the ones that come next. And so we had that. There's a paper in PNAS reporting the first prediction markets on the reproducibility project studies. And it's like a 70% success rate of anticipating replication outcomes. Yeah, so that was great initial evidence. What's happening now, and there's 2 papers in print showing initial evidence for this, is machine learning to do the same thing.
That's what I was going to ask you about next, actually.
Yeah. and the success rates are matching what the surveys and prediction markets are able to achieve. So if that is replicable itself, then we now have a scalable solution for at least a heuristic, right? It's not going to be definitive. None of these things will be definitive, right? There's tons of uncertainty around these, but at least a heuristic to say, ooh, here's some areas that we need to look closer, right?
Okay, so that sort of points out where you should go do your study, or where you should try to get a replicate.
Yeah, right. So like how a funder might look at the score that machine spits out and says, wow, we were really going to invest in translating that to, this new $100 million campaign. The score is kind of low. It's an important finding. Let's fund a replication or a set of replications, or really try to work on verifying it. Right.
It might be quite hurtful once sorry for interrupting you. It might be hurtful. You submit your paper and then the machine spits out that your last year's work is not going to be reproducible.
Right. Yeah. So there are plenty of risks with such scores, right? We know how bad metrics can be abused in science and otherwise. So there is lots of cautions in doing that, in how such a thing would roll out if it occurred and was scalable. We are part of a project right now that is trying to evaluate this at scale that's funded by DARPA in the United States, called the SCORE program. So with that, we are essentially doing the reproducibility project again, but across the social behavioral sciences, so including economics and political science, sociology, education, business, etc. And we have a set of claims that our team is responsible for extracting from papers. And so there's now this database of 30,000 claims, and then we enhance that database with data from all kinds of sources, right? Citation impact, where the authors are from, other information about retractions, whether it was pre-registered, all kinds of stuff just to enrich the data set. Then there are two other teams that have evaluated those with prediction markets and with a structured elicitation technique. So having a group have independent evaluation, then talk amongst each other, amongst people who are in that field, and say, what do we think about this? And then give ratings. And then there are three other teams that are doing machines on the same thing. And all of them are providing scores. And then in the background, on some subset of that set of claims, we are running replication studies as the ground truth to see if these scores are viable. So we'll get a lot of really interesting information from that about whether scoring works, to what extent it works, how much uncertainty, does it work better for some kinds of domains than others, et cetera. So I'm hopeful that that will spur the next round of debates about all of this.
In terms of the data that's coming out, are you going to be able to determine what the causes are? So going back to the original reproducibility project, was there scientific fraud or misconduct that you found, or is this more, a systematic problem with the way that we do science?
Yeah, we have ourselves not identified any specific instances of fraud. Of course, they occur, and there's others that are working on credibility issues that have developed techniques to look for fraud, and that may be that they find some in the samples of studies that we have done. But really, the issues that we perceive as the biggest challenges, and this is not resolved. These are active areas of inquiry to try to understand how much each is having an impact. But the key influences, I believe, are selective reporting, which would be, I do many experiments. I only report a subset. Which subset end up getting reported, right? The ones that are easier for me to publish. The novel result, the positive result, clean and tidy findings. And the ones that didn't quite work or had a messy, I can rationalize to myself why those were bad studies. I shouldn't include them in the report. Or the editors and the reviewers might say, oh, that study, that's a mess. Get rid of that. It's a much cleaner story if you put those other three experiments together, right? So the whole system sort of incentivizes positive, novel, tidy results. So selective reporting. And then the other big challenge is flexibility in analysis and inference. So when I'm working with these data, there's lots of choices I make in my analytic pipeline for what to exclude, what model forms to use, what inference process. And all those decisions might be consequential for the outcome. Now, if I have skin in the game, I need certain kinds of outcomes to advance my career, then I might, again, unintentionally, I'm trying to get the right findings, but I believe certain things and I have certain goals. And so that might shift my biases in how it is I reason about my own data. And the analyses that look better for my interests, I might rationalize as being better. So I think, to me, those are the key areas that are worth addressing. There's lots of other areas that are totally reasonable areas for having low replication rates. And the most obvious one is risky hypotheses, right? So if we're pursuing things that have low prior odds of being correct, we should presume that we will have replication rates below 100, right? If we had a field where replicability was 100 all the time, then that field is probably not going anywhere, right? Because we could say we're just doing things that we're pretty sure are going to work. Or in fact, we're really sure these are going to work. And you do it again and again and again and again and again. And you say, look, we're perfect. We get it all the time. That's not how science advances. And science advances by pushing that boundary, by taking risky bets. So that is low replication rates at the onset of work is not necessarily indicative of a problem. It's when they persist and they unknowingly persist. That's where it becomes a problem.
It seems like there's this underlying theme of, people often talk about publish or perish.
Yeah.
So there's some incentive for people to, they go away, they do some study, they cut the data in a way that looks as positive as possible, and they make various choices. Have you had a look at, have you looked at the breakdown on, do people who are tenured, who have sort of a secure position, do they tend to have higher reproducibility? Is it sort of junior people or people who are not secure, who are sort of still in that fight, who are having more of a problem? What's the breakup there? Do you know?
Yeah, it's an interesting question, and I haven't seen any evidence that shows variation by career stage specifically. It could well be sort of what the hypothesis that you're generating there, that once you're secure, you don't have those pressures, and so you're you sort of naturally move towards more replicable findings. An alternative hypothesis is that the scientific system is an evolving system itself. It has natural selection, and those that are more creative at convincing themselves and others and doing the behaviors that would reduce credibility are the ones that survive and advance. And those that do it the right way at early career stages get selected out. So if that occurred, then we'd see the opposite. Now,
I'd like to know if that was true. That would be interesting to find out if that was true.
It would be fascinating. So it is a way to lose friends, but it is a really interesting question to investigate.
I guess another problem is you don't know the number of hypotheses you could have, right? There's infinitely many things you could guess would be true. And I suppose if you're like, let's say, for example, I think that eating too much cake will make you gain weight, say. So I go and do a study, and I happen to see that the group of people who are eating more cake have their hair fall out, or some other outcome. Should I go ahead and report on the hair falling out outcome, or is that just, because that could be a false positive, since there are unlimited things that could happen in any group of people. What should I do in that case?
Yeah, I think the critical distinction is transparency between what was planned and what was discovered after the fact. Because both of the situation you describe is a very common one for actually advancing science into new domains, right? Is the accidental discovery. Right? We're in exploration. If we only are testing and willing to report those things that we plan in advance, we do not get the benefit of serendipity. And so then it's purely our ingenuity of thinking of things in advance and hypothesizing what must be true or what might be true as driving the findings we investigate. So there is a critical role in advancement in science for exploration. The problem that we've created in the system is that we've incentivized researchers to present exploratory discoveries as things they planned all along, right? Tell a good story in your paper. So I get this result of eating cake makes my hair fall out. Then I generate a theoretical backstory in writing the paper of, it turns out the hair follicles are sensitive to, the rate.
Cake.
It's cake. I was trying to generate ingredients of cake, but just cake itself, right? But but we tell the story, and then that creates the false confidence, Whereas if instead what I report is, we plan to do this study about the relationship between cake and weight. Here's what we planned in advance. And then as we were looking at the data, look at this crazy thing that popped up. Isn't that weird? That's weird. Someone should look at that a little closer, right? Calibrating our confidence based on confirmation versus exploration then helps the literature to start to take on those interesting, low prior odds, but interesting ideas, and then test them again. And that's the key, right? You got to test it again.
So in terms of openness, one thing that I'm a bit curious about, I imagine there's a lot of researchers who are, because there's probably researchers who do some calculation, say, and it's not worthy of publication, it's a null result, so they don't publish it. Yeah. And then some other researcher comes along, does the same thing, and someone else, and someone else, and someone else. And because it's not being published, the same result is reproduced hundreds of times.
Yeah.
So you could, this is not the side of the fence that I fall on, but you could say that by making things open, publishing null results, you're going to reduce the amount of reproduction. On the other hand, if you test something 100 times, the chance that you get a false positive increases, right? So where do you fall on? I guess it's always good to be as open as possible.
Yeah, if I'm going to play to brand, yes, the transparency of everything is of value, and precisely because if I know that others did it, then I might disagree or think it's worth another try or whatever else. But at least I make those decisions with information, and by seeing those 95 negatives, the 5 times that it did come out positive that people were waving their hands about, well, we can calibrate our confidence based on, wait a second, is that just what happened by happenstance?
So actually openness would solve that problem. In terms of, so another thing I'm curious about, have you looked at generating, just made up data, you make a made up study and you get teams to analyze the data and look for systematic, systematic areas where problems creep in.
Yeah,
on the analysis.
There are a few interesting efforts on this. One, the first one that we did was that we gave a data set to 29 different teams and asked them to test the same hypothesis. And this is informally called the red card study. So the data set was soccer matches and had individual information about individuals who got red cards or not, and their teams and who the referees were. It's all a real big sort of complex data set. But the question was, are players with darker skin tone more likely to get red cards than players with lighter skin tone? And so the 29 different teams all got the same data set and analyzed it their way. And what was the result that people were surprised by is that there were lots of different answers. No two teams analyzed it the same way. If you're going by statistical significance, 2/3 of them found a positive result that the skin tone was related to likelihood of red card. 1/3 of them found a negative result. There's wide ranges in the effect sizes observed. And the point was really just to illustrate that there are consequential decisions in the analytic pipeline, because our mindset when we read a paper is that this is what the data showed, but it's actually, this is what the data showed contingent on all of these choices I make and how I analyze my data. And we don't naturally recognize the uncertainty of those decisions and to evaluate the robustness. So that's one part that just, again, sort of illustrates opportunity. A second study that was not done by us that's relevant to your question is an ingenious study that was done in the management literature. And what they did was they found papers that were published that had been the dissertation studies of PhD candidates. And then they went and they found the dissertations that were in, but pre-publication, just what they had done in the dissertation. And then they compared the papers. What was in the dissertation, same exact experiment, what was in the published paper. And they found that what was, and I'm doing the numbers by recall, but it was something like 45% of the results in the dissertations were positive results, and 67% of the results in the papers were positive results. Same data. What happened? Right. So they looked what changed between the dissertation and the published article, and there was lots of findings that got removed from the dissertation. Mm-hmm. There were some findings that got added, and there were some few findings, a small portion, that the result changed. It was negative and became positive because of new choices in how to analyze and report that data. So it just sort of helped to illustrate that things are evolving and not necessarily in the accurate direction. There is bias in the system.
So you learn how to tell a good story by the end of your thesis. I wanted to ask, you might. So you mentioned not just psychology. So that was management studies. That's or something right. You just mentioned. I was wondering if are the social sciences in some sense special in that you do a study 20 years ago, and in the interim, the society changes somewhat, so that. Are you really measuring, let's say, bad science, or are you just measuring society changing?
Yeah, no, that's a very important question, and it could very well depend on the particulars of that finding and what the claim of that finding are. It's very rare in a social science paper for the claims by the authors to be, this is what happened in this particular context at this particular time and will never happen again. Right. The claim that, that you can't make historical claims, and there's lots of very useful areas of scholarship that are about history and about events as they occurred. But most social science, like other areas of science, are trying to come up with generalizable claims. In this particular context, we observe this thing, and what that means for human behavior, for societal behavior and otherwise, is some kind of general principle that we think applies outside of this one context that we investigated at this one time. Now, that doesn't mean that as the theories evolve, they wouldn't also evolve with changing society, right? Because things do change in cultures and society. So the key for thinking about replicability, and this gets into this really rich debates about what replicability means, is can you extract a claim that is presumed to persist and compare and contrast that from those where there's an expectation that no, that was particular to that circumstance, right? So I think that's very ordinary in how theories develop and mature, especially when they're highly underspecified, as is true in many social behavioral sciences, right? I did that in the U.S. Does it apply in the Netherlands? I didn't actually think about it when I was doing the original research, but now I'm confronted with having to think about it because someone wants to extend it. Okay, what might change in the cultural context? So that generative theory is actually embedded and advanced by trying to do replications, because what we're trying to do is say, we think that we're testing the same thing, and now you and I get to debate about whether it is actually the same thing. And if we don't agree that it's the same thing, then we might be actually pulling the threads at what our theoretical predictions are and why we think that and what the context is, et cetera.
Yeah. It'd be interesting to sort of flip the idea on its head and ask the question, what do we need to do across cultures or across times to hold that result fixed?
Yeah.
Like what are the what do we actually need to do?
Right.
But so I wanted to ask actually, so we've been talking mostly about psychology, but how wide have there been broader studies done in chemistry and biology and various other fields, or what's the status there?
Yeah, so there is widespread concern across different disciplines about the nature of reproducibility or replicability, and there's high variation in how much self-examination has occurred in fields. Psychology's done the most, I think, because there's just a real sort of cottage industry and a group of meta-scientists that have really been interrogating these issues for the last decade. But it's not the only field that's been looking at this. Economics has been doing a really interesting work in examining these issues, especially in the context of secondary data analysis, right? These massive data sets. You're not going to run a replication on a national intervention or a data set that was from a particular census year, but you can reanalyze other data to compare it or look at the robustness within that. So the unique aspects of different literatures are fostering different kinds of interrogations of the credibility of the claims. It's also certainly in medicine, in the translation from preclinical to clinical practice, these issues are not new at all, right? A lot of the clinical trials and the federal regulations for which things get into people's arms, as it were, since we are in COVID times, all of that has developed, that regulatory work has developed as a consequence of recognition of these challenges in the financial conflict of interest, right? There's big money on the line. So we really need to have a robust pipeline to assess credibility of what actually gets out into literature. I think the work outside of that is looking at the other areas of conflict of interest, which is my career advancement in relation to my results. So one of the other projects that we're just now finishing up or writing the final 2 papers is a reproducibility project of the same kind in cancer biology. So this is all preclinical work. It was led by Tim Arrington, a microbiologist at COS, the director of research at our organization. And it was a very similar project. We took a sample of studies from cancer biology, tried to develop replication designs for them. In this case, we even partnered with a journal, eLife, and had the protocols peer-reviewed in advance through a model that we promote called registered reports, so that the expert reviews would get on board essentially and say, yes, that design is an effective good faith test of the original study. And then that is a pre-commitment to publishing it regardless of outcome. As long as we follow through with what we say there, they'll publish the result. And then try to assess whether we can replicate the findings. So that's not just us doing this kind of work, but there are examples like this that are starting to pop up in more and more places as communities look at their own research practices.
Are people receptive to that sort of publishing, that manner where you?
Oh, for registered reports. So yes, the key idea of registered reports is if the making decisions about publication based on the results is really the area of key bias, right? You're selecting on positive results, and that's creating this incredible literature. Then let's remove that selecting on results by not knowing what the results are when we make the initial publication decision, and have the review be about the importance of the question and the quality of the methodology. And then the researchers do what they do. And then the second stage of review is not on, are the results exciting? It's, did they follow through with what they said they're going to do? And are they interpreting their outcomes responsibly? There are now 270 something journals that offer registered reports as an option. Only one journal does registered reports exclusively, but 270 something journals offer this as an option for researchers to submit. And it's super encouraging, the early evidence of how it works at reducing publication bias, of it actually increasing evidence of rigor and quality of the research itself, and of the experience that authors and reviewers have in going through the process as being more aligned with how they imagined and idealized science to operate. It's still early. It's been, it started in 2013. Now we're at 270 journals, but there's accumulated experience that is advancing this further and further.
I'd not heard of that. That's a really nice idea. Yeah. Actually, this sort of public. Yeah. Maybe we could talk about some of the other solutions that you're putting forwards to increasing reproducibility and openness in research. So would you be able to say a little bit more about that?
Yeah, so that's one of our major ones because it goes right into the core incentives that researchers face and how it is they plan and execute and report their research. But the other ones really are collectively invested in just improving transparency behind the paper, right? David Donahoe at Stanford calls the paper the advertising for the research, not the research itself. And so I really like that as a mental framing of when I write the paper, it's me trying to write what I think is important for you as the reader to know. But of course, it's coming through all of the interpretations that I have of that. And of course, I can only say so much of what the research was. So one way that we can improve the assessment of credibility and then ultimately improve the credibility of the literature is for you to be able to see everything that I did. So what were the data that I generated? You should have access to that. Sharing data is a good thing. What were the materials that I used, the protocols that I administered, if it was if in a behavioral study, did I have some performance that was involved in framing for the participants? Can I give you a video of that? Right? Sharing all of those materials, giving you the context to evaluate that research will help you assess the credibility and will help you, if you want to try to do a replication, to have access to all of that stuff. And then the last key component is sort of embedded in the registered reports model is commitments in advance to what I'm planning to do so that it's clear what was planned in advance, what it was not. Pre-registration is the general concept. And the goal of pre-registration is to do two things. One is by pre-registering that a study exists, I'm going to do this research, then there is some way of discovering that stuff that gets left out in publication, right? I did 100 studies, I wrote up 5 of them, at least because I pre-registered in a registry, these other 95, you in principle can discover them and say, hey, what's up with those other ones? Oh yeah, those were terrible studies, don't worry about that. But at least now you can evaluate it. The other part of pre-registration is pre-registration of the analysis plans. I say in advance, what is it, how am I going to analyze this data, what I'm going to report, right? That increases it confirms at least the credibility of the statistical inferences that I draw from that. And then once I get into the data and start looking at it different ways for that exploratory process of, oh my gosh, people's hair are falling out as they're eating cake, then it's very clear, oh, I didn't plan that because I made a commitment, but I still discovered it and I still want you to know about it. But now you can calibrate your confidence appropriately.
How can you incentivize people to share raw data? Because, if I do a big experiment and I've spent a year collecting data and immediately everyone else can see that data, then they have I have no advantage from the year of work I've done in terms of publication of analysis. Are there any tools on that side of things?
No, you're pointing at a key challenge, which is we have a sense of ownership over the data that we generate. And partly that sense of ownership is because of the reward system. Like I need to be able to use and mine that data because the paper is ultimately what I'm rewarded for. So there's a couple of opportunities for change there. One is that we can say, okay, the system is what it is right now. When do people need to share their data? We can avoid too much interference with the existing reward system. So the standards that most journals are adopting for open data expectations is upon publication, you share the data. Now, some people in fields where they have really rich data sets that they analyze for multiple types of papers, the criteria is not you need to share the entire data set. It's you need to share the variables and the observations that are needed to reproduce the findings in that paper, not everything. Right, so there are ways to sort of incrementally move towards openness that still respect the existing reward system. But a more comprehensive solution will be to actually make the generation and sharing of data a scholarly contribution itself. Right, so I'm rewarded for when you cite my papers because my papers have more impact, and that makes it seem like I'm doing more.
Or when you use my data now.
Exactly. So if my data is a citable unit, and that's recognized by you as, wow, he generated an amazing data set, then that changes the reward structure. And many people are very happy to share data under such circumstances.
That would be quite a sensible approach. I'm conscious of the time. I realize you have to go away now. So how about we close up now, but with one last question very quickly. So, I want to get a sense for your view of the impact of the reproducibility project, because in the short term, if you have a sort of a small view of things, you might think that this is quite embarrassing for psychology as a field. But actually, on the other hand, this might be just it might be one of the greatest things that's ever happened to the field.
Well, I know which one I prefer. Yeah.
I know which one you prefer, and of course you have to be modest and so on. But I mean, this is actually quite a big deal. I mean, science is reproducibility. So, what's your feel for the impact of this sort of research on psychology as a whole?
Well, I can speak to the motivation for doing it, which is the latter of your examples. The goal of investigating the reproducibility of findings in the field was not to say, let's embarrass the field. I am a member. I love psychology. I'm trying every day to have psychological research advance, get translated, and be effective and support the improvement of society. But the key ethos that really motivates me, and I think many others in the field that have been involved in these efforts, is that ethos of self-criticism, that really science is trustworthy because it doesn't trust itself. And if we can embody that and constantly be skeptical of our own claims, of our own approaches, then we will earn the credibility that we expect for science by identifying areas of challenge that are systemic, that are cultural, that are part of the structure of how science gets done and rewarded, that are social, about the challenges of my ego defense when you fail to replicate my findings or say that I'm wrong, and those individual biases that I don't even recognize as I'm executing my work. Psychologists are particularly well positioned to look at those things because they are social and cultural issues. That's what we study. And so it really, for me, the project and its impact is about showing how psychology as a discipline can help with interrogation of science as a social process and make it operate more effectively.
I think it's something that psychology should be proud of. Brian, it's been an absolute pleasure. Thank you for coming on the podcast.
Thanks for the invitation.